Hello, Taipei Blockchain Week. My name is Manny, and today I'm excited to talk about Polygon ID with you guys, and more specifically, a deeper dive into Polygon ID and on-chain verification. Don't worry if you forget something or if you want to go back to the presentation. There will be a QR code at the end of this presentation so that you can scan it and come back to it with all the resources and etc. So let's dive in. So first off, who am I? I'm Manny. I'm a developer relations engineer, more specifically for the Europe region for Polygon, and my job is to do technical talks, workshops, technical articles, support people on GitHub, and even through the Discord groups and servers for that matter, and different channels to be able to support developers in any way that we can from a technical point of view. Feel free to follow me on Twitter. This is where I normally talk about Web3 and rant about it. I talk about Polygon, I talk about different articles. You'll see me release different things. And a little bit about me, my background is actually in Web 2 to start off with, before moving up to Web 3. I've been in tech for nearly 15 years. I used to be a full stack developer, and I sometimes consider myself an aspiring DevOps, but lately I love being able to create material and educational material to help other developers get unblocked and just be able to build really, really cool dApps on the blockchain specifically. So also, this talk actually was a remix or basically a rehash of an existing talk that was done by another one of our DevRels by the name of Steph. She's one of our US DevRel engineers. She did this talk in Bogota. So if you haven't seen this, I definitely recommend checking out. She does a really, really great job. And this is really just my take on it in terms of her existing presentation and all the hard work that she's put into this. So definitely check that out for ETH Bogota when she did this original presentation. So let's start off with, what information did I just give you? So I told you my name, I showed you a picture of myself, what my job title is, where I work, what my social handle is. This is all the information I give you, but I want you to keep in mind, how are you verifying this information? How is this information trustworthy, and what information is actually true with the information that I gave you, right? I gave you 5 pieces of information, but which one of them is true? And, how do we even decide this type of information, whether or not which elements are true? So let's start with a scenario, and with the greatest scenario of all with SpongeBob. Let's start with SpongeBob driving a car, and he gets pulled over by the by some police officers. They asked him, "Can you please identify yourself? What's your name?" SpongeBob replies, "Well, obviously my name is SpongeBob. It says on my name tag, right?" But in the mantra of Web3, we have this idea of not trusting things, but just verifying it. So there's got to be a way to be able to verify it on the blockchain, or somehow to be able to verify that SpongeBob is saying exactly who he is. Like, how do we verify that he's not just telling some story or inventing a name? There's got to be a way that we can actually verify this, okay? And one of the prime examples of verification today is actually through a driver's license, right? That's coming from a reputable government institution or government body in that sense that's issuing out a driver's license. You give that out to a police officer to be able to prove, SpongeBob SquarePants, that's his name right there on the driver's license, that proves who he is and whatnot, and what he says in that sense, right? But you'll notice that the information that he gave the police officer with this driver's license also has a bunch of other information associated with it. There's the issuer, where this information came from, his address, his physical trace, his birth dates, his dimensions, all this stuff that he wasn't asked for, just his name, but this additional information was divulged to the police officer, right? So in that sense, there was a sense of just divulging or giving too much information, more than what was requested. And this is a prime example of an issue today that's kind of plaguing existing Web 2 solutions, right? There's big tech companies that are just absorbing so much information to be able to kind of get so much, to know you so well, to be able to throw ads at you in a specific way. And really it's as soon as we give that information over, it's less in our control and more in the control of those big tech companies, right? And to kind of give you an overall idea of what that means, you're essentially creating a new identity for each one of these different sites or different service offerings in big tech. And there's actually, in the landscape of things, there's 3 different types of identity offerings: centralized identity, so CI, federated identity, and SSI, which we'll get into later on. But we'll cover just the current landscape, just to give you an overview of what's currently there, and then dive deeper into what we're leading into and how Polygon ID might be able to solve this and whatnot. So let's start off with the first one, the centralized identity and what the characteristics are, right? So it's probably like a single purpose app, so probably an app that doesn't have single sign-on. It's really like, hey, it's a username, like an email, a password, and you probably have a ton of these, and you manage it in terms of multiple passwords in one password manager. It's really siloed, so again, it's only to itself. You have many logins, and if you think about it, you're also kind of creating fragmented identity, right? And what I mean by that is, like, because you've signed up to so many different sites, if your name changed, let's say you get married, etc., you might have to update every single one of those sites to be able to say this is your most recent information about you. And to be honest, most of us are really lazy, and we're not actually going to go and update all those sites. But then what that's part of me doing is just creating a fragmented identity over multiple sites, and that's a common characteristics of centralized identity. Federated identity actually is a little bit more multi-purpose, right? You have one identity, you can go to multiple environments, it's reusable in that sense. And a prime example might be single sign-on. It's not exactly the definition of federated identity. And if you do want to know more about central identity, federated identity, I definitely recommend going to okta.com and looking up these terms. They actually give really long definitions that are very, very specific in terms of what the true definitions of these are in terms of digital identities. But getting back to centralized identity, it's definitely more portable. So you might do something like sign up with Google or sign in with Google, and all your information stored with Google. So you're able to manage a single identity in one place and have it, basically work with different applications. But one of the negative characteristics, or depending on how you look at it, is that that data is owned by big tech. It's really that as soon as you've given that or divulged that information, basically it's owned by them, it's managed by them. You can update it to a certain extent, and definitely there's ways that you can circumvent it in terms of requesting for deletion with like GDPR. But at the same time, it's stored with one single entity in that sense, right? So how do we solve this? And one solution to take it to a step further is self-sovereign identity, or SSI, or decentralized self-sovereign identity. And this is like a solution to kind of combat all some of the negative characteristics that you find with centralized identity and federated identity. So it's multi-purpose, it's very portable. So it's you own your data in terms of what's controlled, and there's no third party involved. So there's no like Google or Facebook in that sense. You own that information, and you're able to prove that information and own that specific identity. And we're going to go a little bit further in terms of what that means, right? And these concepts actually come from a book or come from a concept called self-sovereign identity. So I definitely recommend checking out the book. But basically, it's really about empowering users to own their digital identities, being able to sign information on their behalf, not necessarily through another third party, and really just individuals or organizations owning their data and choosing who is able to access that data, and really just granular fine permissions, and being able to say, hey, who do I decide to divulge certain information to? So definitely check out the book if you have time. So in self-sovereign identity, there's this concept of the trust triangle, right? So we're going to use the scenario of SpongeBob being pulled over. So we have the police officer. In this case, we'll call them the verifier. So somebody who's going to verify that credentials, and then prompts the holder in this case, or the owner, to say, hey, can you verify the information in terms of your name, right? Now the holder receives their information or gets their valid proof in the sense of a driver's license, some verified credentials from an issuer. In this case, I believe it's Ms. Potts, who is like a boating school. So it's a reputable institution that is like an issuer, in this case, that issues out a verified credential, in this case, a driver's license. From there, it's presented to the holder. The holder holds that for just these cases where something he's being prompted in terms of verification. That verification in terms of credentials is shown to the verifier. The verifier looks at the credentials and says, well, it comes from a reputable source in terms of the issuer because it's Bikini Bottom. So in that sense, I trust this, just driver's license. So there's this trust level in terms of a trust triangle between the verifier, the issuer, and the holder in that sense, okay? So where Polygon ID comes in is that it actually implements this solution through zero-knowledge based privacy. So I won't go over all the points, but definitely check out polygon.technology/polygon-ID. It'll go over the different points, but really the main factors that you need to take home with you is that really is being able to have granular permissions of who you decide to give certain information or prove something about yourself without actually divulging or giving any information at all. So, and this is taking advantage of technology called zero knowledge proofs. And this is not necessarily new, but Polygon is kind of made this product to be able to kind of roll up this solution to make it a lot easier and more user-friendly to be able to process this or do this for various on-chain and off-chain verification. So I won't go into details, but again, the main benefits is, again, it's decentralized, it's private by default. There's this trust reputation and it's permissionless. So you don't necessarily need to go through a third party like Google in that sense to be able to do this verification. It can be done directly through the blockchain and through zero knowledge proofs in that sense. So let's go back to the example, right? We have the holder, the verifier, the issuer, the verified credentials, the proof that's given to the verifier to be able to verify those credentials, and there's a trust between the verifier and the issuer. So let's take a real world example in this case, right? Let's replace SpongeBob with myself. So me, I'm the identity holder, right? In this case, the verifier will be like a prompt in terms of script. And we're going to get into this in terms of what this looks like, and we're going to set this up. Hopefully the demo gods are good to me today in terms of like going through and showing this demo. But as far as it goes, what happens is the verifier prompts the identifier. Let's start over. The issuer gives a specific claim. In this case, we looked at it was a verified credential to the holder. The holder holds that in Polygon ID as a wallet, and whenever the verifier or a verifier asks for that specific type of claim to verify that proof of them, they'll prompt the identity holder to create a cryptographic proof, in this case a zero-knowledge proof, which is given over to the verifier to prove something about themselves. So we're going to go over an example to prove somebody is older than a specific age. In this case, I think it's set to 20. If they're older than 20, then they can perform a mint in this case, and they perform an age verification. But through that zero-knowledge proof, what it's doing is it's not saying, hey, this is my age. It's saying, I just met the criteria of that age restriction. So let's say in order to mint something or to get this airdrop, you need to be over the age of 20. And if that's the case, then you're able to mint things. But by doing so, I'm not necessarily giving my age. I'm just saying, hey, do I meet that criteria? And that essentially proves. And the verifier knows that the cryptographic proof comes from a specific issuer in this case, and trusts it so that knows that, hey, this is eligible as well because it's coming from a reputable source. So let's go into practice. So the first thing we'll need to do, and I'll set this up just briefly, is you need to download the Polygon ID app. And I'm just going to load this up quickly and I'm going to show it on my phone here. Just give me 1 second. So let's show a little bit of what this looks like. Give me 2 seconds. Oop. And here's my phone. All right, and let's just share my screen here. And I got it to the full screen mode, and this is what it looks like. Okay, so in terms of Polygon ID, it's a simple app which will hold claims. So this is a wallet, and what you have to understand is that it's not the same as a MetaMask wallet or a crypto wallet. It doesn't hold crypto. It doesn't hold transactions for this. What it holds is all the claims that we talked about in terms of proof of information. Now, right now I have 0 claims in this, and we're going to go in terms of setting up an account and being able to load a claim into the phone to do an airdrop. So I'm going to go over the code as well, but let's set up an issuer to begin with, okay? So the first thing that we're going to need to do is I need to sign into platform-test.polygonid.com, okay? So I'm going to sign in Give me 1 second, get my super secret password. All right, and from here, this is actually a demo. Again, this is beta. It only works on Mumbai right now, but this is to show you that this is a demo issuer in terms of you being an issuer in that sense. Now, technically, anybody can become an issuer. There's ways to do this, but we're going to go through. This is the easiest way to do development as an issuer. So let's say, my issuer name in this case. No legal name. Let's keep the information the same. So you're going to see here that this is the claiming dashboard. So the first thing that we need to do is actually set up a schema, okay? And the schema is going to allow us to say, hey, this is the constraints of what the claims are. And from there, I'm able to create multiple claims from this specific schema. So let's start off. We'll create a schema, and we'll call it. And I just need to make sure, because the name really does matter. We'll need the name. We'll call it KYC age credentials. Okay, so that's capital KYC age credential. Okay, and the attribute name, we're going to name it date. Okay, this also is important. It's case sensitive. We'll be needing this for our proof. And the data type is date that we're going to set to. Right now, currently, there's only Boolean, date, and number that's supported. String is something that we might look at. But the idea is you want, normally for zero knowledge proof or a proof, you want to be able to give a sense of doubt as well. So like if it was, I need you to prove that you make a certain amount of income from 100,000 to 200,000 or something like that. Do you meet that criteria? Yes or no? That's what you're trying to do, is giving a certain range of a doubt to be able to say, do I meet that criteria? I'm not going to divulge what that is, right? And hopefully the range is long enough so that you can figure out what the value is. So in this case, we're going to use date. We don't need a description, and we're going to make a mandatory claim expiration. So what this means is whatever claims that are made from this schema, we're going to make sure that that they have an expiration and that they can expire. And this is probably good practice from a security perspective to make sure that, just like if you were issued a passport, there's an expiration date for it, and you want to make sure that it expires after a certain time. So let's save and offer the claim. So in this case, we're going to set a date. Let's set it to like 1990, January 1st for that matter. And we're going to set the expiration for the end of this month. Okay, so let's generate this claim. Perfect. So we have the generated claim. And what I'm going to do, the first thing I'm going to do is try to get the claim on my phone within the wallet that we talked about, okay? So to do that, I click here on the claim, and you can see that this is the schema that we created. So the format, which is the date and the name of the schema, and the claim that came from that schema, and with the attribute of date, okay? And the value. So if we click on it, we're going to be prompted to a site. Here we're going to go to... Yeah, normally is this not the schema URL. I slightly no, not there. Go back to the the claim link. So let's open this up. That was it, and let me bring up my phone now. So give me 1 second. Sorry there, got slightly distracted. All right, so here's our app. I'm going to first connect to the site with my wallet. So confirm I'm going to connect. Enter my super secret password. I'm going to authenticate, so basically just connecting to the site. From there, it's going to, after it's been connected, the QR code is going to change, and now I'm able to claim, because I've been connected to the site, add the claim to my wallet. So here I'm going to accept it. I'm going to confirm with my super secret password. Oops. 1, 2, 3, 4, 5, 6. And I'm adding the claim specifically to my wallet. And if we go to our claims, we see KYC age credential, and we can see that it came from a specific issuer, the date for the value that we set, as well as the expiration of the end of this month. So that's perfect. So now we have a KYC age credential that's stored within our wallet. Okay, so the next thing we're going to need to do is have a verifier, and we're going to do an age verifier for an ERC20 token. Okay, so the first thing I'm going to do is I'm going to switch over to some code, and let me just briefly just bring up this. So the code that we're going to be going over today is Coding with Manny Polygon ID on-chain verification. This will be moved over to the official OX Polygon ID repo. But if you go through this repo, you will see how to do the ERC20 token, how do you do an ERC721 token as well. And you can even see debugging errors. So like if you get a specific error, how do you handle that? What you need to do to be able to debug that specific error. So all this is within the README, and this is the code that we're going to be dealing with today. Okay, so let's start with the code that we have. So the first thing I'm going to do is I want to look at, we're going to be deploying an ERC20 token. So let's look at our contract. So to start, it's not that different in terms of, it's not that different between an ERC20 token. I just want to, nope. There we go. So we call it ERC20 verifier. It's an Open Zeppelin ERC20, so it just inherits all that from the class. And let's just increase this a little bit. And what you'll notice that's a little bit different is that we also inherit the ZKP verifier.solidity file. Okay, and this is important, and we'll go into the second. So let's briefly look. Okay, we're looking at the token transfer amount. So basically, we're saying only 5 tokens per user can be set up, and then there's a mapping to be able to verify if an address is already minted in that sense, right? So let's look at the ZKP verifier really quickly. So this has a few different functions that allows you to also set up a proof, and this is what we're going to take advantage of. We're going to set up a zero knowledge proof that's based off of this schema that we already set up on our platform.test. What this is going to do is store that on the contract, make sure that, hey, this can be verified also on chain, that this is a claim that's still valid, and that's stored within the contract. And then also we are going to take advantage of this submit ZKP response or whatnot, which is published after we've verified our proof in terms of our age credential in that sense. And it's going to hook into a before proof and an after proof function that we have basically in our ERC20 token. And you'll see that here we've overwritten it with our after proof, and you'll see that if the transfer request was, if they've minted more than 5, or if they're minted before, then that they shouldn't be able to mint. And then what happens is if they're valid, they'll be minted 5 airdrop tokens in that sense. So let's start off with just deploying this. So this might take a little bit. So let's go node bin hard hat run deploy scripts deploy, and the script that we're going to use is our deploy script from here. We're just going to deploy this specific script. So it's called ERC20 deploy, and the network is Mumbai. And let's just double check that in our hard hat config file. Yeah, Mumbai. Perfect. So I've already set up my environment variable. So you'll set that up normally with your private key and any other your specific RPC for Mumbai in that sense, and it's deployed to specifically Mumbai. And we'll just double check that transaction went through. So 1 second. So we're going to go to Polygon scan, and let's just verify that transaction quickly. And we can see that the contract has been deployed. So perfect. So we have our ERC20 token. That thing has been minted, etc. It's been deployed. So the next thing we need to do is we need to set up the verifier, specifically set the ZKP proof or whatnot, ZK proof on the contracts to make sure that it knows how to handle those requests for a proof, for handling a claim in that sense. So what we're going to do is we need to take advantage of this script called ZKP request, and this is going to update on the contract to be able to handle things. So let's go down this list of what we're doing here. So there's a specific format that needs to be set up. The circuit ID is just like how it's a query language that's on Polygon ID that I definitely recommend checking out if you guys haven't. It's oxpolygonid.github.io, It will go over also different query params in terms of the query language specifically used for creating schemas. But here, this is just the format that we're adhering to. The validator address is actually an address that's deployed to Mumbai, so you won't change this. You can kind of see that's deployed to Mumbai. This is used constantly for us to be able to verify that the claims are still valid. And so we wouldn't change this address. We're going to give it the name of the contract. In this case, it was called ERC20 verifier. The schema hash is what we got from our platform ID. So if we go back here, I'm going to copy my schema hash, which was here. And I need to be able to paste that in for the actual schema hash. This is very important, okay? And then secondly, I need to be able to paste the contract that was deployed. So in this case, this was the contract that we just deployed. Everything else we need to adhere to. So you'll notice that the schema comes from, we establish a hash specifically from that as well. And then we're going to go over some of these query params that we just need to factor in. So slot index actually refers to, slot index 2 refers to where the value is stored in terms of the attribute. Now this might look confusing, but this is what this means. So we have attribute 1 and attribute 2. You can actually have up to 2 attributes for every claim, for any claim that you kind of set up as a schema. What this is saying is that slot index 2, in this case, this index, attribute 1, is where the value is stored, not slot index 3. So this is 1, 2, 3. Slot index 3 is attribute 2. It's saying that this is where our value is being stored, okay? And from there, we're able to do a comparison with the operator. In this case, the operator value is 2, and 2 is less than. So we're saying that whatever the value that's stored in slot index 2, it must be less than the value. Okay, so I know it's a little bit confusing, but at the same time, it's just like, hey, whatever your value is, it's got to be less than, and then whatever the value is. In this case, we're just putting this as an array, and this is saying that the first value of that array, we need to fill up like 64 spaces for it. And then what we're going to do is say, hey, it has to be lower than 2002 January 1st in that sense, or yeah, less than that. And less than that means like somebody who's essentially older, right? So if it's less than that, then we're good. And all this is going to do is now perform a request to be able to push that to the contract to be able to make sure that the schema is saved to the contract. So let's run that right now. Bin hard hat run scripts and EC220 ZKP requests network Mumbai and run it. I have some additional console logs, but we should see that transaction go through. So let's just double check that. Give it a couple seconds. And while we're waiting for that, the next thing that we're going to need to do is we're going to set up a front end to be able to interact and be that verifier prompt for our application. We're going to take advantage of we already have something set up. It's called HTML QR claim. So all this is a Vue.js React app that just basically shows a QR code. And we'll show that quickly, what that looks like. So I'm going to go to HTML and go yarn dev. And if I go to localhost 5000, let me just show this quickly. It's only a QR code that's going to be, and this is going to be our prompt, but it's important the way that the format of that QR code is, and we're going to make sure that that's set up correctly. But let's go back to our transaction to see if it's gone through. Perfect. So let's go to our contract. We can set ZKP request is set up. So now we're set to be able to have the prompt work properly in coordination with the app in terms of that verification for the claim. Okay, there's another thing that we need to do here. So because the ZKP request is set up in the contract with a specific format of, hey, slot index of the value, the operator in this value in that sense, that also needs to match on the front end for our QR code. And we essentially follow this with, this is the schema of the schema of our proof requests. And this is what makes up the QR code. So we have a unique identifier, right? The type in terms of how it's kind of interpreted, and then our body for our transaction data. So we're saying it's going to be deployed to this specific contract address. And the method ID we don't change because this is just a hashed this is the hashing of the name of submit ZKP response. So it's just saying run this function after it's been complete, and it's on this specific chain in terms of 80,001, which is Mumbai, and the network name, which is Polygon Mumbai. Reason, this can be just specifically for whatever you'd like. In this case, it's just an airdrop for ERC20. We have the scope, which are a set of different criteria that we're adhering to. So basically saying these specific standards is set as an array. So this is the first scope of that. And just like we saw before in the ZKP request, we have an atomic query. So it's setting the same format. And the rules is a query. The allowed issuers, we set it to all in this case because whitelisting is coming, but the idea is that you can specify specific issuers. If you remember correctly, we actually set it up and there was an issuer number that was given to us in that format. So if we saw on the application, this is, let me bring it up just briefly. See on our app here. You'll see that there's the issuer number. We can actually use that as a whitelist specifically for this too. And you'll notice that the requirement for this condition is the attribute in this case. And we saw that in our platform test, which is here date, which is matching that. So it's case sensitive. And it's got to be less than 2002-0101. And that was the same that we had here for our ZKP request, the operator, which is less than, and then 2002 January 1st. So those things need to match. But we also need to change that the schema URL and the name of the schema need to match in this case. So that would be retrieved from here when we go to our schemas, and we go to, if we click it, we'll get this schema hash and we'll get the schema URL, and we're going to replace that. Luckily, what I did here is I just loaded this as a basic object in our front end. And the only things that we need to replace are the contract address, which we deployed. So here I'll place that. And then all the values are the same. So we get the proof request, and all we're doing is like we're making a copy of it. The deployed address is what's new, and then we're going to set the query params. So in this case, date is less than 2002. That's exactly what we needed. And then we're going to replace the schema URL, in this case here. So I'll copy this. Let's replace the schema URL. And then secondly, we're going to copy the hash, the name, schema name, and we're going to paste it here. And then we're set up. And if we should see everything, it should be updated on our QR code. Now that we have that set up, let's watch. Hopefully the demo gods will show us the magic of everything working. All right, so the first thing I'm gonna need to do is I'm going to scan the QR code. It's gonna ask for a proof request. It's gonna generate a cryptographic proof. Ask for my super secret password. Then it's going to switch over to our wallet, because to be able to process the transaction, because if we look at remember our contract, it's going to hit ZKP, submit ZKP as a, here we go. It's going to hit submit ZKP response. And from there, we actually need some Matic to be able to make sure that this transaction goes through, right? So let's follow along. I'm going to switch over to my MetaMask. Give it a second. MetaMask takes a few seconds to load. So it's going to connect to the site. So basically to our Polygon ID app. It's going to switch over. It's generating the proof. Switch back, and it's going to confirm to process the transaction with Matic. And then all we need to do is go back. No thanks. And then we're going to look at our activity for the transaction. So let's look at this one. It says, let's view it on Mumbai. Let's give it a second to load. And it was successful. So let's actually copy the contract address in this case so that we can see it that our wallet was successful. So let's go back to our wallet, and I'm going to import a token. So this is the address of the contract. It already pre-fills the name. We're going to import it. And voila, we can see that we've been airdropped 5 ZK ERC20 tokens because we did an age verification to make sure that we're older than the year 2002, January 1st, essentially. So that is how you do an on-chain verification. There's actually other ways you can do things in terms of off-chain verification, which is hopefully we're going to be doing another workshop specifically with that. You can definitely check out github.com/Polygon ID for some of the tutorials. There's a issuer protocol, there's on-chain verification, verifier integration, and there's a lot of other resources that I definitely recommend checking. Again, you can go to platform.polygonid.com to be an issuer, to be able to issue out specific claims that's stored onto your wallet. And these are all the resources. So there's a GitHub tutorial. There's the other GitHub tutorial that was the repo that you just saw. There's a front-end code sandbox. There's a Notion. There's a platform issuer that we just showed. There's the ID talks. And I also recommend, if you want to get a holistic view, again, of everything, I definitely recommend checking out university.polygon.technology. And there they have some really, really great courses on zkVM, Polygon ID, POS. I definitely recommend going through these. These are great resources to be able to really fully understand the different types of technology and the different types of scaling solution that Polygon has to offer. So definitely check that out. And if you want this presentation, you can definitely scan it, and you should be able to take advantage of this. So let's dive into some common questions that I normally get for Polygon ID. So the number one question I normally get is, well, actually two questions I normally get is, one is that, could anybody be an issuer? Like if you're your own issuer and your own verifier, that does kind of defeats the purpose? Yes, that would defeat the purpose if you are the issuer and the verifier in that sense, right? Ideally, what you would have is you might actually have a government institution be an issuer in that sense to be able to verify that information, and or a reputable source that is trusted by that verifier, right? And I'm using the government as an example, but it can be anything in that sense, right? So a government institution might issue a specific claim for your ID that's stored on your phone. And from there, whenever you're trying to verify, oh, am I a national of this country, or I'm a national of the EU or North America in that sense, I might not divulge where I live or divulge like my exact country, but do I have these specific rights? And I can verify that if the verifier prompts me to be able to divulge that information, and all I do is, do I meet the criteria in one of the whitelist countries to be able to get into a country? Yes or no? Yes, I didn't give you any information, and the verifier trusts it because it's coming from a reputable source in terms of a trusted issuer in that sense. So the idea right now is that platform-test is really just a building ground for a lot of developers to be able to build on top of, and essentially just test out and test the waters, because it's currently only supported on Mumbai. We will be posting it to POS mainnet relatively soon, but as far as it goes, like, this is a good time to be able to start playing around with the technology, because it's really, really great and ripe to be able to work with. So yes, technically anybody can be an issuer right now, but the idea is that the idea for Polygon ID is to make it open enough so that a lot of other people can become issuers and do their own verifications in terms of who they trust as an issuer, right? So some of the second questions I get most common question is like, well, what if I lose my wallet? Then what, right? Well, you would probably be in the same boat if you lost your passport, right? Somebody might be able to steal it. But the major difference, I think, is a few different security factors that play into this. So one, if you lose your wallet, if you lose your passport, like, somebody could start using it right away or try to, impersonate you. But the way that you would go is you would go basically to, your government and be your government institution and say, hey, you should make this passport invalid. So in this case, I think there's almost like 4 different security methods for this that you might factor in. So one of the easiest ways is like, well, your Polygon ID has a password. Your Polygon ID app has a password, so you'll be able to access it. Somebody needs to be able to know your password. And I know I showed 1, 2, 3, 4, 5, 6 are mine. Typically, you wouldn't show your password to somebody else when you're in front of them, right? So that's one way that you would keep, make sure that somebody doesn't have access to your claims that are in your wallet. Second thing is, you obviously probably have a password on your phone to be able to kind of make sure that somebody wouldn't be able to get into your phone in that sense, right? Thirdly, you would have, like we talked talked about, we have claims that have expirations. So ideally, just like your passport is going to expire in a certain amount of time, you would have a claim that would automatically, be expired after a certain amount of time and then just become invalid, right? So what would you do if you lose? You probably go the same way for a passport, to go get a new passport or a new claim in that sense from the issuer to be able to verify that information. So that's one. Is that a third is you'd be able to make sure that you set expirations to specific claims. And the fourth method actually is actually that the claim can be invalidated from the issuer itself, because what's happening is that there is still one last check from the verifier to see on the blockchain that if that claim is actually still valid, and based off of that, if it is, then it proceeds. If it isn't, then it'll invalidate. So a claim can actually be invalidated from the issuer itself. So that's a fourth way that security can kind of be handled for making sure that claims aren't shared or in that sense. So those are some of the typical questions that I have. As far as applications, it could be, proof of funding. I believe ING came up with something like this in terms of proving if you have a certain amount of income, right? And which is great with that is that, hey, I don't know anything about you. I'm not going to, discriminate you based off who you are to be able to say you should be approved for a loan or not. So there's some ideas like that. I've seen projects where people are wanting to divulge specific medical information about themselves, but not actually divulge who they are because they don't want to be taken advantage of when it comes to insurance companies, because typically when a patient, depending on what country you're going to a doctor and you're going to go do a test checkup to be able to submit certain information. Sometimes they find some things that might be wrong about you, and that information is kind of transmitted back to insurance companies, and your premiums go up and you're paying more money for something that you're penalized just for checking information. And this is unfortunate because you're trying to contribute to science and you're trying to give data out in an anonymous way. This is a great way to be able to kind of share that data without actually having to divulge who you are and say, yes, I have these symptoms, et cetera, and contribute to the DeSci movement in that sense. And again, there's a lot of different types of applications that can come from this. And the main takeaway is that none of your information is stored on chain. So there's none of it is public in the sense that, hey, who you are, et cetera, none of it's stored there. We're just using a decentralized way to be able to verify those credentials coming from a trusted issuer and a verifier that trusts that issuer, and the way to prompt that and create cryptographic proofs. And again, all that information is stored in terms of the sensitive information is stored on your phone. And as far as it goes, there's still a last minute check with no information that has related to that specific claim on chain to be able to make sure that verification goes through. So if you did enjoy this presentation, definitely send me some love on Twitter. Say that you found it very, very interesting. If you have questions, feel free to hit me up on the Discord or at me on Twitter publicly. I'm happy to answer questions. I have multiple articles as well on this, the code repo with different scenarios, etc. So feel free to reach out. And that's it. That is on-chain verification with Polygon ID. So I just want to say thanks, everybody. All right.